I'm going to show you how to write a Makefile by hand from scratch. And this is the final Makefile that we're going to write. I just recorded the whole thing. So this is literally what we just wrote in about an hour, I guess. And what it can do is build a C project that looks like this. This is what the C project looks like. So it's a couple of C files, a couple of libraries. And the Makefile can automatically detect those files, so we don't have to specify the file names anywhere. So we can just make everything, and we can make run. And another very cool one is make watch, and it will automatically watch our source files. And if we change anything, Makefiles, am I right? And we just do that, and we forget the new line, or we don't forget the new line. And everything just updates. And if we make a mistake, we see an error. If we fix it, we see instant dopamine when we are programming. So that's really cool. Oh, one thing I forgot to mention is I also wrote an article, like a written version of this whole thing. And I spell everything out in text. So if you prefer that, you can check it out. You can also steal the code by just copying the source code here. And it's pretty much 7 levels of Makefiles, going from super simple to every time a little bit more complexity, but more functionality as well. And we're slowly building up the complexity of our C files. So we're starting just with main.c, and then we slowly build that up. And we at the same time we slowly build up the complexity of the Makefile, which is pretty cool. So let's dive in. All right, so let's start with level 0, which is no Makefile at all. And I'm here in a completely empty directory. So I'm just going to create a main.c file. And I'm going to add some standard stuff. And just print some garbage to the screen to test it. No, I'm going to say hello. Okay, return no negativity. Return 0, and that should be fine. Jesus. Okay, and we have to include something for puts. What is that? Include standard IO. Yeah. Okay, looks good. If you don't mess with Makefiles, the way you would compile this is just cc main.c, right? And then you just get a.out. You can run a.out, and it works. But what if you want to make, let's remove this, a.out, and look in the files we have these files now. Remove a.out, and I want to call it main. So instead of cc main, I'm going to output main, right? That's the most standard thing you might do to just compile a single C file. And now we can run main, and that works out as well. But what have I told you? You can use make for this without having a Makefile. So let me again remove main. All we have is a main.c, but we can make main, and that works because if you tell make, we need to make main, it just has some default rules and some pattern matching, and it's going to look for a main.c. And if we have a main.c, it knows, okay, we need to do this. And this is exactly what we just ran manually. But instead of running this manually, we can now just use make main. And sometimes I just use this. If I don't have a Makefile, I just do this quickly. And it's just nice. So now we have a way to compile without anything. And this even, since this is all done by make, it properly takes the cc variable to change your compiler program. So if we set cc to gcc and then make main, it says main is up to date because we forgot to remove it. Okay, we have only a main.c. If we do cc equals gcc and then we make main, it uses gcc now. And the same we can do for the C flags. We can set that so something like this. Again, it's up to date. And now it's using this C flag. So we can do that. And this is kind of silly to do because you might as well just do this and then do this, right? And then this the same thing. But if you have your C flags somewhere set in the environment, so let's say C flags is this, and you export that, now you can just run make main, just like that. And it uses this W all because it's in the C flags variable, environment variable. So let's unset that and move on. Okay, this is level 0, no Makefile. C flags. Okay, that works, level 0. But if we start to modify C flags and maybe the compiler and stuff, we might as well just set that up in a Makefile, right? So this is our first Makefile, finally. And the most vanilla way to make main out of main.c in a Makefile that you might see in the wild is this. We want to make main. It depends on main.c. And the command, and you have to put a tab here. And my tab, for some reason, is only 2 spaces, but I don't care, so I'm not going to change that. cc main.c output main. That is just everything spelled out, a lot of duplication, but this is the most basic form of a Makefile. And now we can make main, and it runs, it's up to date, so let's remove main first. Now we can make main, and it does this, but this doesn't really give us anything extra. Without the Makefile, it was doing the exact same thing. One thing we can do different now is we can just run make. And so first remove main. We can just run make, and that also works because if you just run make without any rule, it just uses the first rule, which is this. So that's cool, but make does a lot of things automatically for you. So we can get rid of this and save it and remove main and make again, and it's just working. It just knows how to do that, and we can run it to see that it actually works, and yes, it does. We can even get rid of main.c, and we just say we want to make main and just figure it out and remove main, and now I can just run make, and it works. So this is the bare minimum Makefile, I guess, that you can come up with. So now we can start adding features. So maybe we want to add those C flags, right? So we can set that up here as a variable, and we don't need to do the bash style variable like this with no spaces. We can just give it some breathing room. And I can do W all and maybe W extra. And now if we remove main and make it again, we get those flags, and we can also set CC to something else, and that also works. So now it's using GCC. Cool. One thing that I often do, that I often want to do after I compile is run, right? So you can do make, and then you could do it like this, but we can also do this in our Makefile. And I'm just going to add a little run target. And I'm going to say this depends on main. And it knows that it knows how to make main. And we can actually get rid of this because it already knows how to make main without a Makefile. It's because of these default rules that it has. So if we save this and we remove main again, now we can just make run, and it's, oh, I forgot to actually run it. The command that we want to run is main. So what we're telling here is like make run. The target is run. So if we run make run, it's going to run this thing. It depends on main because we need to make main first. Otherwise, we can't run it. And then we are going to run it. So that's what this does. Let's try. And it's going to run it. But if we remove main, you can still run it because now it knows we need main first before we can run this. So you will see a compile command first like this. And the second time you run it, it will not compile it again. So that's pretty useful. And the other thing that I've been doing constantly is remove main. So let's add a little target for that. And the most common name for that is clean. You see this all the time. And this doesn't depend on anything, but it just runs remove main, just what I've been doing, manually. So now we can do make clean, and that's like the convention. Let's make it first, and then it runs it, and now we can make clean. But you see the issue here. If we run it again, we get an ugly error, and we don't like that. So let's fix that by adding the -F to force it, and also to just suppress errors. So now we can make clean. Even if main doesn't exist, we can run it. And there's actually a weird little variable available for us called RM, capitalized, in that just provides this variable for us. And this is the way to reference a variable. And that's doing the same thing. So make clean now is also running RMF. I don't really know if this is useful, but yeah, we can use it. The other thing that now is a little bit confusing is we can run make run, and that will compile and run. But if we just run make, it's also going to compile and run. And I don't expect that if I just run make. So let's catch that default one using all. This is something you see as well in the wild a lot. And if we want to make all, we just want to make main. That's for now, this is all we want to make. And again, it knows how to make that. So now we can make, and we have nothing to do. Make clean, that removes it. And now if we make it again, it just compiles it. And if we want to make it run, then we do make run. Okay. Pretty cool. One final thing. There's an issue with this Makefile, because right now, what make is built for, like the intention is to literally make files based on rules. And we have 3 rules now. These 3 are rules, but all, run, and clean are not supposed to be files. They are just like little actions or commands that we want to run, and we don't want to consider them files. But make thinks these are supposed to be files, and we can show that by, for example, creating a clean file. So now we have a clean file in our directory. And if we now try to make clean, make says, oh, clean is already there, so we don't need to do anything. It's also up to date because clean doesn't rely on anything. So we don't have to do anything, and we don't remove main now because of this clean file. So you could say the solution is to just remove the clean file, but what if there is a file that, has the same name as one of your targets, but it's not supposed to be a file? You can mark those as phony. So you can either do it one by one, like this, and say clean is phony. It's not supposed to be a file. And now, let me add that clean back and see if it fixes the issue. Did I save it? Okay, so now we can do make clean, and now it runs the command properly because it just, even though we have a clean file in there, it knows, okay, clean is not supposed to be a file. We just need to run this. So that works. And you can do that for run as well, because run is also not supposed to be a file. All is also not supposed to be a file. What I like to do for this small file is just do it all in one line. So all, run, and clean are all not supposed to be files. And that's how you kind of configure that. So that's pretty good for just having a basic main.c file. And we have some functionality now. So if we now, we're editing our C file, we can just make run really quick, and it just compiles and runs. It's super useful. Let's move to the next level, which let's check out the article. It's about immediate feedback. And actually, I want to just go to the top and look at level 2 over here. So we're going to add a little watch command that's going to watch our source files, which currently is only main.c. And every edit we make, it's going to recompile and run our program, which is super useful for a nice feedback loop. So let's see how we can do that. The thing I want to add here is watch. So if I run make watch, I want to start doing this. I want to start getting into this feedback loop. It's not going to depend on anything. And the tool I'm going to use for this is called enter. So let's look at what that is. It's called ENTR. And enter is just a little command line tool that can run arbitrary commands when files change. And that's exactly what we want to do. So the way you use enter is you give it a list of files to watch, and then you give it a command to run. That's basically it. And it has a bunch of options. But the way we can make a file list is just to list all the C files. I could also list main.c, but I think everything.c makes more sense in case we add more C files later. And that's our list of, so what you get with that is just the list of C files, which is currently just main.c. Then we just pipe that into enter. And then here you give it a command that you want to run. And we already have a command available, which is make run. That's what we want to do whenever our C file changes, or one of the C files. We just want to make run, and make can figure out that it needs to recompile or not, and then it runs it. So let's see that in action. Now we can do make watch like this, and it will, the first time you run it, even though you didn't change the C file, it just runs it for the first time. So you can see hello there. And now if we make a change and we add something new, it recompiles and it runs it. And we can remove this. And now you don't see anything. And every edit we make and save shows up. So that's really useful for a nice like feedback loop and getting into the flow. Also, it's useful if you have some kind of bug, some error, you see the error immediately. And when you fix it, you see it immediately get resolved. And one other thing I want to do is I want to clean up the screen every time we run it. So enter has an option for that, C, to clear our screen before we run it again. And now we have to quit, which you can do with Q. So I hit Q, and now I can watch again. And as you can see, it cleans the whole screen, or clears the whole screen. And now if we make an edit, it just shows the compile command and then it runs and everything works. And the error shows up and now we fix it and then the error is gone. So that's really nice. One little thing that I don't like is just seeing this all the time. And that's something you can suppress. By default, all the commands that you specify in a Makefile are printed to the screen. And that's, for the compile commands, I kind of like that because it's then you can just see what's happening. But running, that's not that exciting. So you can suppress that with an @ symbol. And I guess for remove, I also want to do that. And maybe for watch as well. Let's just add an @ in front of it. So now make clean will just work and doesn't print anything. Make watch, same thing, or make run just compiles and runs. If you run it a second time, it just runs the program and it doesn't print anything else. So now if you do make watch, it's even cleaner because now it just says the output, and any change we make, you just see the bare minimum and you see the compile command. That's the only thing. That's to show that you know it's recompiling. So yeah, pretty useful. I think that's all for getting immediate feedback. So the next level is compiling multiple files. We're finally gonna break out of just our single main.c. So let's add another file. And I think, yeah, what I used in the article was just a random number generator. So I'm gonna add a random number generator.c and a .h. This is just a standard pattern. So let's start with the .h. I'm gonna say if not defined rngh. Then we define it, and that's just to make sure we don't include this twice. And then what I want is maybe a float rng random number, a random float. And that's gonna be void. And then we can implement that in the .c version. Oh, we have to include the rng.h. And then we can implement this just quickly for this example. I don't want to spend too much time on this, but return rand. It's going to cast to float. And now we get this huge number. I want a number between 0 and 1. So let's divide by the rand max. And we need to include stdlib, I think, .h. Yeah, okay. Now we can use that. We can include RNG. And we can just printf maybe some RNGF. And we can say u1f, maybe .2f. And clean that up. Okay, now we can make run. And it breaks because the Makefile doesn't know about this other C file, right? So we're trying to import this header file, and that works, but the implementation is in the .c file, and we don't tell Make to compile that. So what you would do without a Makefile, the simplest way to compile this is just to cc main and RNG, and that's it. And now we get an a.out, and that should work. Yeah. Oh, and I forgot my, we can fix that later. I forgot my new line. Yeah, so, and if you want to output main, you do this, similar to what we had before. And this is just a one-liner compile command to compile multiple files. Yeah. How can we translate this into the Makefile? Currently, we don't even have a main target because we just let make imply the default behavior, which is just main.c. It doesn't know about rng.c. So we can give it a main target and let's just say main.c rng.c. And then we can just do the same thing. Yeah, that's the most vanilla way to do it. So cc main.c and rng.c, and the output is main. And now we've pretty much done the same thing in our Makefile. Let's make clean and make, and that runs, and it compiles, and make run, and that works. And we can make watch, and that still works. And let's fix the new line, and that works. And now we can even change rng.c. And we can just add something here, and that updates too, because we are watching any C file. So now the list of files we're watching is this main.c and rng.c. We pipe that into enter. So everything is now working. But we can again rely on our, one thing is not working. The C flags. If you want to include the C flags manually, you can do it like this, C flags, and now make clean and make, now we have the C flags, but we don't even need this. As long as we tell make, this thing depends on main.c and rng.c. As long as we do that, it works. So we can make clean again and make, and it runs the same thing. It's literally the same thing. It just adds more spaces. So that's nice. And we can even go a step further, and it's already implied that main depends on main.c. So we can delete that and just add the other C files that we might have in our project and make clean. And another trick is you can add multiple targets to a single make command. And so we can make clean and then we make all. And that works. We could also make clean and make run, and everything works. So now, as every time you add a C file, you just add it here, and that's all you have to do, and everything works. And that's it for level 3, I would say. Now, level 4, let's add a source directory and organize our project a little bit better. And because right now, our project tree looks like this. It's just all these files sitting there in the root of our project, right? That's not, for a single file or maybe 2 files, it's fine. But as it grows, you want to organize things a little bit better. So let's make a source directory. And actually, I'm just going to make clean and grab all of these. Oh, also remove that a.out. Oh, and remove the clean. Like there's a lot of garbage in our project right now. Okay, so all our source code is pretty much these 3 files. So let's move them to here. And now our project looks like this. So we have a Makefile in the root. The Makefile should always be in the root, in my opinion. And then all the source files are in source. And now everything breaks because we don't know how to make rng.c because, we say main depends on rng.c. Like when we run make, it runs all because that's the default. And then it's like, okay, we need to make main. That's here. To make main, you need to run, you need to make rng.c. And actually, I want to move this here and have all our phony things here. And actually, watch is also a phony, except for all, because that has to be in the top. But then, yeah, I want to put main there. Anyway, make doesn't work now because we say that main relies on rng.c. And rng.c doesn't exist anymore. It sits in source rng.c. So if we do that, it says nothing to be done, which is a bit strange. And the reason for this, okay, the reason that this now doesn't work is we cannot get away with not specifying the command. So now we have to do all of this. So instead of that, we can keep it the same. And we can do another trick. We can use the vpath variable that make uses to look for files that it cannot find in the root. So if we set vpath to source, it will encounter this main relies on rng.c, and then it's going to look both in the root but also in source for this file rng.c, and it is in source. So I think this should work now. And now you can see the compile command compiles source main.c and source rng.c into main. And this is what our file, so now we have a main in the root that we can run and everything works. So we can make clean and it still removes main, which cleans everything up. Make run works, and make watch is also broken now because we have to look inside of source. So we could either do this, now make watch, and we go main, maybe capitalize it, and add this. And now it does do that. Another way you could do this, this is really flexible for enter, to create this list, like this list looks like this. Another trick you can do is just use find, and we're going to find in source, and then you get this list, which is slightly different. We have the 3 source files, and actually having .h in there is also good, but we get to that later. But the only thing we don't want here is the actual source directory. So find source, and then the type is going to be file instead of both directories and files. So now we get a proper list that we can pipe into enter. So I'm going to use this, and yeah, so now we can make watch, and that works as well. So our random number generator is a little bit broken. It's always giving us 0, but yeah, let's look at that later. But yeah, if we change rng.c, it also updates. And now if you make a change to the header file, it also refreshes, but it doesn't recompile. And that's something we will fix later. And that's probably at the very end only. But yeah, this is just adding some structure to our project and putting all our source files into a source directory. And the only thing to make it work is pretty much adding this vpath. And then, yeah, everything just works. And then the custom commands that rely on those files might also have to be a little bit different. But I think everything is set up properly now. So yeah, let's move to the next level. So I have a source directory. And now, yeah, we can look at separate compilation or like compiling things in steps instead of in a one-liner, the way we compile now is like this. We take the .c files and we output directly into the executable. Once you start to add a lot of libraries to your project, you might want to compile things more efficiently. So if you change one library or one source file, you only want to recompile that single file and link it all together instead of recompiling the whole thing, all the files. And another benefit of doing compiling in steps is you can compile in parallel, which starts to become useful if compiling takes more than a couple seconds, I guess. Then it starts to get annoying with the fast feedback loop. So let's look at how this is done without a Makefile. So instead of compiling everything in one go, we're going to compile the main.c, and then we're going to compile the rng.c, and then we're going to link them together. So there's going to be 3 commands now. So the first command is we're going to compile source main, and we're going to say only compile it with -c. And what that gives us is a main.o in the root. And so I'm going to do the same for source rng.c and only compile, not create an executable. And that gives us this. So now we have a main.o and an rng.o. We can use the main.o and the rng.o, and we can output main. And that worked. And we can run main, and that works. So this is pretty easy to set up in a Makefile. And this is where a Makefile starts to really shine, because a Makefile can keep track of all the files that depend on each other. And now we're starting to get some kind of dependency graph where the final main executable that you care about depends on the .o files. And the .o files depend on their respective .c files. And so it can figure out, based on the modification time of your C files, which .o files need to be recompiled. And then things start to become a little bit more efficient, which makes sense as the project gets bigger. So how do you set that up in the Makefile? You say main depends on, it doesn't depend on a C file, it depends on the O file. So main.o and rng.o. And let's see what that does. Make clean, and then make. And now it's going to say, okay, we still had those old .o files sitting around. So it just compiled main. And yeah, that works. But we now have to update our remove. So let's just do that immediately. And we're going to also remove anything .o. So make clean. So before, we still have those O files sitting there. Now we want to make it clean and make sure that the object files are gone, and they are. And I think this is not going to work. So, oh, okay, it's going to work. Yeah, everything works because, never mind. It's just magic. Main knows that, make knows that main depends on main.o and rng.o. And there are implicit rules that just say, okay, how to make this. But let's spell it out first. So let's spell out these 3 things just to avoid any confusion, because what's happening here is we want to compile main.o and rng.o into main, okay? But then how do we make main.o? We create another target, and we say main.o depends on source main.c, and then we want to compile source main.c into main.o. And I think we can get away with only this, but maybe just spell it out completely. The output should be main.o. Okay, and we do this for RNG as well. So I'm going to substitute main and replace it with RNG globally. Yeah. Okay. This is the 3 things that we manually run, spelled out in the Makefile. and we can make clean, and we have a clean tree, and now we can make it, and now the tree looks like this. We created the two .o files in these first two cc commands, and then we link them together. We take all the O files and create the main, and it's just, there's no magic going on. This is all just spelled out literally in the Makefile. But as you already saw, we can get rid of this, and it still knows what to do. Make clean, and we have nothing. And we could say, just make the rng.o file, for example. And then it's going to run this, and that's perfect. It's exactly what we want. And now it created this, it created the rng.o. And then we can make main.o also works. And then we make main, and it works. And we don't even need to do that. We can make clean. And of course, if we just make main directly, it knows to first make the .o files. And yeah, so this is all the default rules. We can even get rid of that, and it just knows what to do. And we can probably also get rid of this. Let's try that. Yeah, I already had that before. Yeah, okay. Make clean and make all, and it just works. So this is pretty nice. And now, as you add a lot of new libraries here, you will have to add them here as a .o, but then everything just works kind of magically. And when you change a certain file, it only recompiles that file, and we can do that. We can see that live by doing make watch, and it's working. Let's edit only the main file, go back to lowercase, and now you can see that it only compiles main.c, and then it links everything. It didn't touch rng.c. Same if we add something random here and we save this, it only recompiles the rng.c, and it links everything together, and everything works. So this is a pretty good setup. So this is separate compilation. Okay. Now, next step is something that's annoying. All right, so we only have one library, but as I'm working on my C project, I might add more and more libraries. And every time I add a new library, so maybe I add some vector math or something, vec.c, every time I do that, I have to update my Makefile. And I wanna try to kind of let the Makefile just detect all my libraries automatically and just grab everything, compile it as needed, and just make it work magically and automate it more. Because I want to really get to that set and forget level where I can just take a Makefile and I never have to touch it again unless I need to like edit my C flags or something. So in order to do this, I want to make a distinction between our entry point C files, the main.c, and our libraries. So I want to add another level of directories. And yeah, this also makes the project look a little bit cleaner, because here, as you have if you have 10 libraries, you will have a .c and a .h for every library typically. And then you have all these double names stacking together, so that looks kind of ugly. So let's move it all into a source, into their own dedicated library directory. So that's in this case called RNG, and I can move them in there, and yep, looks good. So now our tree looks like this. So we have only our direct entry point files, which is typically only one file, sitting directly in source, and then the libraries are all in subdirectories. And that's the way I like to do things. And then we can let our Makefile detect this and automatically detect our libraries. So the way we can do this is, first, I'm going to say my source folder is called source. So just to have a place where I can do this, and then I can remove this repetition. So I can say this is our variable source. In case I would ever change that, I can just do it in one place. It's probably not going to happen, but yeah, this is just good practice, I think, to add more variables and reduce some repetition. The second thing I want to do is I want to detect all my .c files in the source file that are libraries. So the way I can do this is maybe lib sources. That's what I'm going to call it. And I'm going to use a new concept called a wildcard. It's maybe not a new concept, but it's like a keyword in a make that you can use. And then you can just say anything in source, which is just the same as doing this, but now it's a variable. Anything under here that's in any directory that is anything.c. So this will match rng.c, but it will not match main.c. And we can check out what this value is by just adding a dummy or debug target, and we can just echo out with an @ to suppress the echo statement. And we can say lib sources equals lib sources. And now we can make debug to check that out. And it's actually the first one, so we can just do make. But as you can see, it detects our rng.c. So that's already a step in the right direction to automatically start getting to a place where we don't have to specify this RNG anywhere in a Makefile. The next thing, let me think. Yeah, I want to get to a state where I can just compile this. First, maybe let's just not use any fancy variables and see how we broke our make system by adding this extra RNG subdirectory. So make is now probably broken. And yes, it is, because first of all, our main.c is now trying to import rng.h, but it's in rng/rng.h. And there's a little bit of repetition here, but I'm okay with that. We can do some tricks to get rid of that, but I think the complexity of that is not worth it. Yeah, so now, well, we tried to fix this first error. Let's try to see what happens now. It's going to say, okay, we're going to, the first one works. We're going to compile main.c into main.o because that hasn't changed. But now we say we cannot find, we don't know how to make rng.o. The reason for that is that it cannot find, it cannot find the rng.c file, because now it's like in a level deeper. So what we could do is say it's in sources and then rng. Maybe that fixes it. Yeah, that fixes it. But that goes against the whole point of this, which is we don't want to be specifying these library names in our Makefile. So we could use something like a wildcard here, maybe, which, yeah, that probably works. Like a wildcard, and we do this, and we turn this into a star. And I guess that works, right? Yeah, that works. And we could call it a day, maybe. Is there any downside of doing this? Eventually, I'm going to get rid of this vpath completely because I want to have more control over what's happening. But let's make clean, look at our tree, and then make, and then look at our tree. So it puts all the .o, okay. Yeah, okay. One downside of this system is as you grow your project and add more libraries, all those .o files get dumped in your root of your project, which is a bit of a mess. So, okay. The new approach is going to be get rid of vpath, and I'm going to use my lib sources to determine the new locations for all my .o files. And I think, yeah. Okay, so my objects, or maybe my lib objects, so those are the ones corresponding with like rng.c, for example, the rng.o, that is going to be, and then we're going to use a new keyword called path subst, I think. Yeah. And that takes 3 arguments. It takes some kind of input, which can be a list of file names. And then it's going to match a pattern. And then it's going to kind of substitute that into a new pattern. So let me just show you the example. Yeah, and I want to be debugging this. Okay, let's, so the last argument is the input list. So that's going to be my lib sources. And then the pattern that we want to match is going to be very similar to this because that's what they look like. But instead of these asterisks, we're just going to say this percentage sign. And this is called the stem. And then you can take this and put it here. So if you put the exact same thing, it's going to just match the same list that we got in. So now lib objects is equal to lib sources. But what I want to do is instead, I want to put this in a new subdirectory called obj for the object files. And I'm going to reference that here. And then instead of a .c, it's going to become a .o. And this is not making anything. This is just a list of variables. And we can debug all of that here. Let's echo out lib sources is equal to lib source. This is just printing stuff. And then lib objects. And we can just make debug to see what that is. So my lib sources, it's currently only 1 because I only have 1 library. It's going to be the rng.c, and then the corresponding object file is in object rng.o. And that doesn't exist now, but that's where we want it to end up. So let's add a new library called vector. And I'm just going to add, like, I don't know, vec.h and vec.c. And I want to like quickly set this up, maybe a dot product, just for the sake of testing vec. And this is probably not very unique, but it will work for now. And we will do a, we need to define the vector. I'm going to just call it vec, and I'm going to say it has an x and a y. And it needs a semicolon. Yeah, okay. And then I want to have a float vec dot product, which takes in a vec A and a vec B. And it returns vec. And that will return the A.x times B.x plus A.y times B.y. Okay. Okay, that's a one-liner. Okay, going back to the Makefile. Now, this wildcard should pick up the new library, the vec, and in the lib objects, it should be reflected. So let's check that out. And yeah, it works. So now we have RNG and vec, both the C files and the object files. So now, instead of just giving this .o file, we can now pass in this list of object files. So let's try that. It's probably not going to work out of the box because it's now in a new subdirectory. But we can do something like this. And now we don't have to specify the names of our libraries anymore. So let's see if that works. And no, that doesn't work because there is no rule to make main.o, which is kind of strange because before it knew how to do that. Isn't that interesting? So if we try to do make main.o, it just doesn't know how to do that anymore. That is. So if we have vec. Oh, of course. That is because we removed the vpath. Should we just keep the vpath for now and see if that's, it should be the variable maybe. I think that's, yeah, that's why. So we add these lib objects. Okay, I think that's why, yeah, that's why it didn't know that, yeah, now it knows how to make .o, the main.o, but it doesn't know how to make that rng.o object that we say we need here. And the reason for that is now just getting more complicated. So we probably need to give it some pointers on that. So we could spell it out, but then again, we go against the whole point of doing this. So what we can do is we know that all the object files are going to be inside of, or at least the lib objects are going to be in obj in that directory. And then it's going to be some pattern.o. And I think we can use that and we can say, okay, that depends on anything that's in. Actually, this is exactly this pattern, right? So we can take this pattern and we can say, okay, whenever you want to try to create a .o that matches this pattern, it depends on the corresponding C file. And maybe that's enough. I don't know. Let's try. Okay, it doesn't know because probably because we are specifying a more complicated path, I suppose. So we have to spell it out. So it's going to be, we're just going to compile. And now we can use some new stuff again. Some magic variables that Make has, which is the variables always start with $, but then dollar left. That means the first target that you specify here, the first prerequisite. And we are just going to compile to the output of another magic variable, and that's our target, which is $at. Yeah. See if that fixes our problem. And now, okay, we're making progress. So now it's gonna actually run the right thing, but we're gonna output in some directory that doesn't exist, and another subdirectory that doesn't exist, and whatever. So you could make those directories, but again, then you would have to know the names of the libraries. So you don't want to spell it out here. So instead, I'm gonna add another command. Which is just a make dir command with -p to make parent directories too, and to also don't care if it already exists. And the directory you want to make is another magic variable. And I think you have to put parentheses around this. And it's going to be @ which is the target, but then the directory of the target, which is @d, which is a special magic variable that Make gives us. And then it should make the directory it needs. So it will do make dir p obj rng. That's what it will run probably, if everything is correct. So let's try. And yeah, it works. So first we make the directory obj rng, and then we do the command, we compile rng.c into that directory. Same for vector. And then we link everything into the final main final main executable. And does it run? Yes, it runs. Yeah, cool. Actually, let's use that vector. Let's use that vector thing that we added. So vec, and let's do some kind of, I don't know, the float dot product is going to be vec dot, and just do it inline. I think you have to do like this, right? And yeah, let's just do 1.2 times by 3, 2.1. And another one is 0.5, 0.2. Okay, and then we print that out. Dot is And I've got a new line and add the dot. Okay. And that works. Cool. So yeah, now the only thing I don't like is that the main.o is here. And we should probably just move that to the object directory, right? And when we make this, it says nothing has to be done. When we make a change to main and we make it again, it will only compile main and it will not compile vec and RNG and then link everything. Because the RNG and the vec.o, they already were fine. They were up to date. So that's working. Okay, I'm going to say main.o has to be inside the object. Can we do that? Can we just do this and then it will figure it out? Okay, that is because we forgot to remove main.o. So let's clean that up. And look at, okay, if we want to clean now, we will remove main and we want to remove the directory of all the objects, right? So now we want to remove rf. So then it doesn't really make sense to use this anymore. We could add a -r after it, but it's kind of like ugly. So I'm just going to do this. Yeah, and so it's going to remove the main executable and the object directory entirely because we're using this makedir, so we recreate it anyway if we need it. And I can actually suppress the output for the makedir command because I don't want to see that. So now we can make clean and that works, and make, oh, it doesn't work. Interesting. We still have a duplicate symbol. Okay, interesting. So now when we make main, it thinks we depend on both main.c and main.o, which doesn't make sense because we already took main.c and made main.o from that. So that's why it gets some duplication. So that's why I like seeing the actual compile commands and don't suppress that. So the way to fix that is now we can probably get rid of this vpath and we don't need that magic anymore. And that's now works perfectly. Okay. The only thing that's not working now. So if I now want to change this to GCC and run this again, I can see that I'm not using GCC at all, which is kind of weird actually, because I was expecting main to be using GCC actually. Oh, wait a second. We're not even making main anymore. That's a bug. Okay. Yeah, so now, okay. Now our main target gets so kind of customized that make is not implying anymore the compile command for this. So we actually have to do this, and yeah. So we're gonna link all the objects. So we want to have this entire list of stuff, which is a magic variable hat, and then we are going to output magic variable at, which is main. Okay, let's try that again. So now, yeah, we should see 4 compile calls, like 3 compile commands and 1 link command. And yeah, okay. And that's all working. And now if I change something in main and I do make run or just make, it only recompiles main.c. Yeah, okay. But if I want my compiler to be GCC, and it doesn't work because I'm using CC. So I should use the variable instead. That's better. And same here. Now it uses GCC if I want to, but I don't want to do that. And it also should use the flags. So that's only required for the compile command. So here I want to do the C flags. And that should work now. So now we have those flags back that we were missing. And usually you want to do LD flags here, which is currently set to nothing, so it doesn't change anything. But in case we need LD flags, like LD, we just leave it like this for now, but you can show that you can set them here if you need to, and that works. It doesn't change anything now. Okay, we are now at a pretty good stage. There is only one thing that's not working properly. Let's run our make watch, and everything seems to be working. If we change main and we capitalize, we capitalize something, it recompiles the right file and it reruns it. All good, all working. We can change the vector implementation if we want. It changes the number. That works. But if we change the header, it might look like it works. Like we add another thing here. You can see it refreshes, but it doesn't recompile. And that's a problem. Because sometimes you have a bug in your header file, or you have something that changes the runtime of the program in your header file, and you wanna make sure to recompile if a header file has changed, right? So another way to test this is if we have nothing to do, but if we touch one of our let's say vec.c and then make, you can see that vec.c is recompiled and then everything is relinked, which is good. And then if you run make again, nothing to do. But if you touch a .h instead and then remake, it says there's nothing to do, because make doesn't know about the header files. It doesn't know about the .h files. So we want to do something like put some .h here to actually not here, but here. Maybe the corresponding .h. And then it kind of knows that it should do that. Actually, maybe that would just work if we do that. This would sort of work. Let's try this and see what happens. Okay, we recompiled vec, and then we relinked it. What we didn't do is we didn't recompile main, and we might, main.c. And main.c is importing vec.h. So main.c should probably also be recompiled when, I'm pretty sure it should. So this doesn't really solve the problem. So there is a better solution for this, and that is using some compiler flag. And the flag is mmd. And this is bringing us to our last header dependency. So dependencies based on the header files. Yeah, so let's add that. And then we're done. Okay, yeah, the mmd flag. And I talk a little bit more in this about this in the article, because there's a couple of flavors. But I believe mmd is what we want. So let's do a make clean all. It all runs the same, but you can see it's using those mmd files now. Every time that it takes a .c and it makes a .o, it does something. And if we look at our files, we suddenly have all these .d files, and they are sitting next to our .o files, and they are dependency files, and they are just plain text, so you can actually look at them. So let's do a fancy like tail number a lot, and then just object anything .d. So we have 3 .d files, and the contents, it looks like this. And this looks exactly like a Makefile rule, right? But you can see all those .h files and also the .c file. So we say that main.o depends on main.c. We already knew that. But now it also depends on rng.h and vec.h. Why? Because main includes them. So main, if you look at main.c, it includes these two. So that's why it depends on them. And then the same goes for rng.o. It depends also on rng.h. So now every time we change, let's say vec.h, we're going to recompile main.c into main.o. And we are also going to recompile vec.o. And there is a very easy way to include those using include. So we can include all those .d files. So every time we make those objects, we can also make maybe the dependencies. And I call them deps. And we don't have a new directory for that, so we don't have to do that. But I'm going to just use the same as lib objects. But I'm going to say they live inside of, okay, this stays the same. They live inside of objects, but instead of the .o, they are .d. And let's debug that. So I'm going to wait with this for a bit. Let's debug this deps. And see what happens. So now you can see the dependencies are vec.d and rng.d. But we're missing one. We're missing main.d, this one. And the reason for that is that we base it on only our lib sources. We don't use our other sources, which is main.c. And so we can start adding a little bit more flexibility to the project and add support for multiple entry points, which I don't know if we ever need that, but we can just do that by saying, I'm going to have not only lib sources, but also bin sources. So my bin sources are the direct files under source, and my lib sources are, there. So we can still distinguish between the two. But now we have access to everything, and we can also say all sources. And that's going to be my bin sources and my lib sources. And this is how you concatenate. It's super simple. Just add a space and that's it. So now all sources is looks like this. And let's debug that. All sources is now all my .c files. So if we use all sources as the source for our dependencies, it should work. All sources. So now we can run that again. And now my dependencies are the 3.d files. Okay, so let's include them, see if that works. Let's include my deps. And it says nothing to do. We can do, again, we can do the touch test. Touch source vec.h. Let's now touch a .h and see if that reruns our compilation. And yes, it does. So now we recompile main.c because it imports vec.h and vec.c because it also imports vec.h. And then we relink it. So that's all working. Let's make clean and make again just to see, oh shit, we have an error. And I already knew that was going to happen. The reason for that is now we have this list of dependency .d files, right? But that list is generated based on the C files. So we don't have these files. We don't even have the object directory right now because we cleaned it. And so we're trying to include files that don't exist. So fixing that is simply adding a dash in front of the include to ignore missing files, pretty much. Ignore the errors. And yeah, so now we can make, and everything works. And if you now have a session of make watch, is that still up to date? I think it is. If we now do a make watch session, we can just start updating things. And actually, let's fix our random number generator a little bit. Yeah, this is just, okay, instead of this, I think the reason why it's always 0 is because we should just call rand a couple of times. And yeah, okay, now it has some different number. But now let's test and change a .h file. I don't know. It does recompile. And now if we make a mistake in our header files, we see the error. And if we fix it, it's fixed. And yeah, that's pretty much it. In the article, I added support for multiple entry points. So instead of main.c, you might have another .c in directly there that you want to compile to an executable. And oh yeah, one more thing we can do is clean up, add another directory called bin for our executables to just store everything neatly into its own place. So let's make it clean first. And then we're going to have a bin directory. And I'm going to have, let's do bins. All my binaries are going to be probably very similar to this. So let's just do this. And they're going to be source.c. That's what they're based on. And then I want to add only the bin sources. And it's going to be in bin, and then it has no extension. So now our bins, let's check it out. Our bins is now only bin.main, but if we add another .c file, we see that now our bins are 2 files, and we might want to do that. And we might want to auto detect this, which we're already doing. Yeah, so I'm gonna, now I have this bins. So now if we want to make all, we could just say, make all the bins like this. And that might break something because, yeah, bin another, we don't know how to make that. So we can add one last thing to this. So now we're hard coding main everywhere, and we can get rid of that if we want. So the way we can do this is say, yeah, I want to say anything inside of my bin directory with this pattern. I'm gonna need an object with this same pattern .o in the object directory. Let's see what that does. And we get an error because okay, another is now not working. Let's get rid of that for a little bit before we fix everything. Let's first fix everything for main, and then yeah. Okay, now we are failing. Why? Okay, it's failing. It's a very cryptic message, but it's failing because the bin directory doesn't exist. So we already know how to fix that. Just add this. It's the same concept. Let's try that again. And it works. So now we're automatically detecting. So now we can actually add another thing. This one and do int main void. Okay. So now we can make everything, and it's going to run a couple more things. So it's going to create all the library .o. That's our RNG on our vec. Then it's going to create the another .o. It's going to create the it's going to link everything we have into another. So it's going to link vector and RNG into another, even though we don't use it. And that's the only limitation of this approach, but I don't think it's that bad because it's all in the same project. So we're going to assume that you need the local libraries that we have. But that's the only limitation. And now we have in our, we can look at our files. And now inside bin, you can see we have main and we have another one. So we can do bin another, and that prints out another one. So we now automatically compiled that as well. And that's pretty cool. And if I do this and make, that works. I'm just checking if I didn't make a mistake. So let's just say I save vec.h and I make again. I have to compile another. I have to compile vec. Yeah. Okay, that seems to be working. Yeah. So now all we have to do is just get rid of that hard-coded main. Actually, when I do make run, I just want to run one of our entry points. So maybe the main one. Let's just give it name, and the name is main. And now everywhere where we reference this, we can also create an executable. The final executable, the main one, is going to be bin main. And yeah, and now we can reference that instead of this whole thing. So we can just do executable, and it depends on the executable. Anything else? Yes. Removing main doesn't make sense anymore. We now want to remove our bin folder and our object folder for a proper cleanup. And this is still fine. And we can remove the debug. And I think this is our final Makefile. This is what we start with when we run make. It builds all of this stuff. And now we have this. We can run bin main, and we can run bin anything else. We can add libraries. Pretty cool. Oh. Okay, we need, our exec is wrong. I didn't test it. So this should be name. Sorry about that. Yeah, now make run is working. It's compiling everything. And no, it's actually only compiling main, because run is kind of a special case. It only depends on our whatever we put in name. So we could change this to another, and now we do make run, and it runs the other one, and all we have to change is this. I think that's useful. That just allows you to have more flexibility, have multiple entry points if you need that. Because sometimes you might want to add a little entry point that can load in a library or load up a file and save out a file, or do, I don't know what you're doing. But one final thing that I might want to add is a variable ldlibs that is common if you do things like, if you want to use raylib or something for graphics, you need stuff like this. And now you can just configure that at the top of everything. Yeah, that's about it. Cool. If you're still watching, you're crazy. Now just thanks for watching. And I know this was a really long one. There's actually 2 more things that I think we could still do, but I'm gonna do that later, maybe. One is a release build, so a more optimized build with like optimize flags and no debugging. So for, and the other thing is testing, like running automated tests using the Makefile, just orchestrating it with the Makefile. That's kind of nice to have, and it's something that should be included in this to make it a true set and forget thing that I want to be using. If you want to see more of this type of stuff, like I'm planning to do a little bit more C programming videos, perhaps. If you're interested in that, let me know and let YouTube know by doing all the things. Thanks for watching. I hope you're having an amazing day, and I will see you in another video.